Welcome to the video tutorial on Pearson Correlation Analysis. In this video, we'll see how to test the assumptions of Karl Pearson product moment correlation coefficient. We'll demonstrate the procedure to do the analysis. We see a model table and see how to report it. So let us look at the data. So I have a data here with the variables happiness, self-esteem, anxiety, sleeplessness. So since Karl Pearson product moment correlation coefficient that we are focusing here is a bivariate correlation, we can take two variables now, happiness and self-esteem. So let us have a hypothesis here. Happiness is not related to self-esteem. Can be a null hypothesis. Now, what are the assumptions that has to meet before we do Karl Pearson product moment correlation coefficient? Now, let's look at the assumptions first. The assumptions are two continuous variables, that means data has to be continuous. So we have happiness and self-esteem. Both are equal interval data since it's measured by a scale. And so that are met, that assumption is met. Second one is linear relationship between the variables. So it means there should be a straight line relationship between the variables. That means happiness and self-esteem. Let us go back to the data first. For that, I have to draw a scatter plot. So let us draw it. Click on graphs here. Then chart builder. You have to go to a scatter plot. Select the simple scatter plot here. Take the variable. It's taking some time. Yeah. Take the happiness variable or any of this variable to the x-axis. Take the another variable to the y-axis. Plot the data. Waiting for the graph now. We have a graph here. It looks like a straight line. So let us plot a line here. It's a kind of straight line and some exceptional cases are here. So I consider this as a linear relationship. That means happiness and self-esteem may have a linear relationship. Now, so that assumption is met. Now, going back to the next assumption. This next assumption is there's no significant outliers, and the last assumption is normal distribution of the variable. We can test these two assumptions together. So let us go to the data once again. Go to analyze. We'll find explore in the descriptive statistics. Go to explore. Take the variables happiness and self-esteem to the dependent list. Now go to plots. You will find the factor level together, box plots, to check the extreme values. Check the normality plot with the test, and not very important. I'm just unchecking this. Continue. Okay. So we will get a result, a set of results. There are so many parameters to check whether data is norm distributed or not. I'm going to focus on the analysis, that is specific statistical analysis to test the normality. So there's a test called as Kolmogorov test and Shapiro test. I will rely on Shapiro test since it is a small sample. So this data tells me, yeah, the data is normal distributed. The significance is greater than 0.05. So I will say that Shapiro test tells me both the scores of self-esteem and happiness are normal distributed. Even we look at the QQ plot and the other plots, it also tells me the data is normal distributed. Now, second one, look at the box plot for self-esteem. There's no outliers here. Yeah, no outliers here. And same way, if you look at the box plot of the happiness, no outliers here. So here, I would like to conclude that my assumptions are met. So I would be going towards Pearson correlation. Okay, now the procedure to do Pearson correlation is go to analyze. In that correlate, bivariate correlation. Take happiness and self-esteem to the right side. Pearson by default will be selected. Two-tailed or one-tailed test based on nature of the hypothesis. By default is there. I would suggest to keep mean and standard deviation also. That will help us to make the table in a better way. Now click OK. It's very simple. So we have variables here, happiness and self-esteem. Now look at the table. First table is descriptive statistics, gives us mean values, standard deviation values and sample size. Now we have happiness and self-esteem, happiness and self-esteem. It's a kind of 2 by 2 matrix kind of pattern. Now let us look at the results here. Happiness and happiness, the variables are same. The value, the correlation value is 1, the highest perfect correlation. We don't need to look at that value because it's the same value. Now our objective is happiness and self-esteem. So look at this value, 0.623 is a positive correlation. We will find 2 asterisks here that indicate it's a significant correlation. And it also can be interpreted from the significance value below it. So this is significance value for the 2 tail test, say that 0.000, that indicates lesser than 0.01. So I may conclude that this correlation between happiness and self-esteem is significant and a very strong positive here. Now you will find that this values here, this diagonal 111 values here. Okay, consider this as a diagonal line. So upper value and lower, so same, because happiness and self-esteem, this value will be same as happiness and self-esteem here. So we can take any one of this value. Okay, so this is how we interpret the results. Now generally we don't keep two variables for the correlation. Usually tend to be a intercorrelation matrix. So how do we do that? For example, we have few variables here such as happiness, self-esteem, anxiety and sleeplessness. Why don't we do all the analysis together? So let us say analyze, in that correlate and bivariate correlation, take all variables together and do the analysis. So we'll get a better table here. Okay, now this can be converted to a better format in APS style. So I may delete this significance level here because it's already presented with the asterisks here, and number, so the repeating value 32, 32, 32 like this. So I may delete that also. So I may retain all the other values and include mean and standard deviation here, and I present in a different way, in a good way. So this is a model that I may suggest. So if you look at this table, happiness and mean value, standard deviation value as per the first table. Now happiness and happiness. So here happiness I am giving as a number here 1, and this is number 1. This also indicates happiness. So happiness and happiness is 1. I am not interested to know what is the relation between happiness and happiness. Definitely it is 1. Now happiness and anxiety, happiness and self-esteem, happiness and sleeplessness. Okay, this is the table, and P, it indicates 1 star indicates lesser than 0.05 and 2 star indicates significant at 0.01. So how do I report the scores? So for example, I may report like this. Summary of the correlation analysis presented in the table 1 indicate that happiness is positively related to self-esteem. Happiness is positively related to self-esteem here. Okay, now R, that's a symbol to represent Pearson correlation. 30 is the degree of freedom, and the correlation value is this one, same value, and significant 0.01 level. And negatively related to sleeplessness, the same pattern, whereas the relationship between happiness and anxiety is insignificant. This is a correlation value, and is present like P is greater than 0.05. So this is the way we can present a correlation table also. Okay, I hope you enjoyed the video. Thank you.